All right, welcome to the Math 136 live lectures for week 5. We're in module 5 content. My name is Debbie Yaus, and I am one of the lecturers. If you've been here every week, you haven't seen me yet, except for last week when we did multiple sessions for the reviews. We are rotating between people, and this week is my week for module 5 content. So you probably have seen the live lecture schedule. I'm just going to open it here to remind everybody that if you need to come back to anything, you can come back to this. And when you are in this document, instead of scrolling and scrolling and scrolling for what you're looking for, if you click this little icon on the left that looks like a little notepad, you can jump right down to this week's content. And so this is what we're going to cover and try and talk about tonight. So in this week, Module 5, you've got Part A is Section 4.3 and Section 4.5, very closely related to talking about quadratic functions and inequalities. One section is functions and the other one is inequalities, but uses a lot of the same information. Then in Part B of your assignment, you would be working on Section 5.5 and Section 5.6. You already did some material in Chapter 5 before the midterm. That was up to Section 4, and now we're coming back to end Chapter 5. This is talking about polynomial and rational inequalities, and again, that's going to be related to 4.5 with quadratic inequalities, and then talking about real zeros. There's a lot. I'm not going to be able to talk about everything. I'm going to try and hit on some of the most common places that students have questions or trouble areas in, say, my lab as well. So I'm going to start with Section 4.3. So in Section 4.3, I'm just going to refer to a couple things. I have pulled all of this that I have written on the screen from your textbook. So if you go to your e-text, all this information is there. I just want to highlight a couple things before I dive into some problems. So you know that you're working with quadratic function when you can recognize that it takes the form of f of x equals ax squared plus bx plus c. That might not be the only form that you see it in though, okay? But if you don't have it in that form, then you will have it probably in what a lot of us refer to as vertex form in the math world. I've seen it called other things, but that's kind of the common way that it's referred to. And you can actually take something that's in ax squared plus bx plus c and transform it into vertex form. The name itself implies that you can get the vertex out of this equation. And so it's an ordered pair H and K that if you pull that from the equation, you have the ordered pairs, H being the X value, K being the Y value. That tells you where is the vertex point of your parabola. That also allows you to identify the axis of symmetry. Those are two things that are really important to your parabola, especially when you're graphing, okay? So I'll go over an example with that. The other thing is the direction that the parabola opens, which is dependent upon whether or not you have a positive or a negative a value at the front. And so notice both formulas, depending on which, or both equations, depending on which way it's written, have that a at the front. It's the same a in both equations. That's the only thing that's really similar between the two. And welcome back, Samuel. And so we're going to focus on getting that vertex, and there's a formula that you can use to get that vertex, and that is right here. And again, I'm pulling all this from your e-text and from the material in your modules. So you probably want to learn this. So the x value is given by the formula negative b over 2a when you have it in ax squared plus bx plus c form. And then the key of remembering what is the y value is that, remember, when you have f of something, that means y. So when you find the x value as negative b over 2a, you just plug that into your function and that's going to give you your y. There's some other information here. Again, I pulled all this from your text, just kind of extra little bits that I might talk about when I get into the actual problem. And then the book gives you like two options of how you can work through these problems. So again, I encourage you to be reading your e-text if you don't normally regularly do that. So I'm going to start with problem 12 that's from your 5A homework. So I'm going to go directly into MyLab and pull this from that number 12. So let me get that up. And again, if at any time you're not seeing what I'm talking about, because the sharing is not showing it to you properly, let me know. But on this number 12, it's giving you an equation, g of x equals negative x minus 3 squared plus 8. And it wants you to identify the vertex, the axis of symmetry, whether it's concave up or down, and then we're going to graph it. So I picked this one because we're going to use the actual graphing tool in MyLab, which sometimes can be a little tricky because it's not the same as what you would do if you were graphing on paper. And it's also really not the same as what you would be doing if you had a graphing calculator. So you have to know how to use the MyLab tool. So what I'm also going to do is I'm going to grab a screenshot of this to put this on a screen I can write on easily. And then we'll pop back in here when we do the graphing part. Okay. So the first thing I need to do to identify the vertex in part A, and my pen is stuck. Give me 1 second. Doesn't want to switch. There's always some type of technology problem. I'm going to go to a different screen and see if that, oh, now it's completely stuck. I'm going to pause for a second. All right, so if we want the vertex, the first thing I see is that it says to type it as an ordered pair. So you also want to write it in the correct format. So I look at this and I decide, okay, which format is this in? Well, this is directly in the format of a times x minus h squared plus k. It's not in the ax squared plus bx plus c format. If it were, then I would have to use my little formula to find the vertex. But because it's not, I'm looking directly for the h value and the k value. Now, a couple things to note. The formula itself comes with a minus sign inside the parentheses with the x and comes with a plus sign outside of the parentheses with the k. So you have to be careful about your sign usage. So I see a 3 and an 8 in the places of h and k. So that tells me that HK is 3, 8. So I should be able to put that here. Now, hypothetically, let's say, what if instead this was x plus 3 squared minus 8, okay? And I'll even just throw in, I'll change my function name. I'll change it to h of x. What if it was that? Well, if that's the case, I have to be careful because I don't have the same signs as what the formula contains. So what this tells me is that instead, this function was negative of the quantity x minus a negative 3 squared plus a negative 8. Because normally we don't write a subtraction of a negative, we change it to a plus. And so that right there gets rewritten as a plus. So we have to know that that meant that the value actually being subtracted was actually negative. And then same thing, we don't typically write things as plus negative. We would just write that as subtraction. So again, we'd have to know that, oh, if I see a minus 8, that implied that the actual k value was negative. So if that's the case, the HK would actually be negative 3, negative 8, okay? So that's just hypothetically because, you get different problems in different numbers. And so you could see that variation of this problem. But right now we should just have positive 3, positive 8. So I'm going to go back into MyLab to enter that. I click in the box. I can use the little template for the ordered pair if I want, 3, and then use my cursor to make sure I get in the blue box so I can put in 8, check my answer, and we're good to go for the next part. So now it's going to ask for the axis of symmetry. The axis of symmetry always is a vertical line, and it passes through the x coordinate. So now of the vertex. So now for the axis of symmetry, the H value is what you want. So for us, that means we want X equals 3. So vertical lines are written as X equals H for this purpose. Okay, so all vertical lines start out X equals a number, and in this case, it's that H value. So I'm going to put in X equals 3, and you want to write it as an entire equation. So notice here under in parentheses, it says type an equation. The biggest mistake I see students do is they'll just put in the number 3. If I check my answer right now, it'll be wrong. Okay, so I need X equals 3. The other mistake I see is students write Y equals 3, and then that's also wrong. That would be a horizontal line. So I get X equals 3, check my answer, I'm good to go. So now I want to know, well, is the graph concave, up or down? It's a little toggle here, so up or down, okay? Oh, I'm so glad that clears up a lot for you, Samuel. And so if I go back to my list here, the concavity up or down that I highlighted in pink up here has to do with whether or not the beginning value is positive or negative, the A value. So concave up is going to be like a bowl. It can hold water, is how I've had teachers explain to me way back when. Okay. If something is concave down, then it doesn't hold water. Okay. And so that's kind of the difference of what you're looking at here. So for our problem, we had just a negative sign in front. Well, that negative sign actually means a -1. So there, that means A is -1, which is less than 0. So therefore, this should be concave down. So if I go back to the problem, I should be able to choose down from the toggle and do a final check with that. And we're good. Now we get to the graphing part. Okay, and so I'm going to click to enlarge this. And again, if you're not seeing the graph pop up on the screen, let me know, but I should be sharing my entire screen, so you should be able to see any pop-up windows. So remember to, look at what it says up here in the yellow strip at the top, because it kind of guides you as to what you need to do. And if you can't read the whole thing, do what I do, just click that double arrow and you can see the rest of it. So it says click the graph, choose a tool in the palette that's over here on the right, and follow the instructions to create your graph. So we need a parabola. So this is a line next to the arrow. I don't want that. Then this is absolute value. And if I leave my cursor just hovering over it, it gives me a written description of it too. Okay. So if you don't know what the shape is, just leave your cursor there without clicking and it'll tell you what it is. This is a parabola, and it says it's a vertical parabola. This one would be horizontal parabola. That's not what we want. And so we want the vertical parabola, whether it's opening up or down for concavity. So now the directions up here say click the graph to plot the vertex. So we said the vertex was 3, 8. So I need to do 3, 8. And so you can get as close and you can watch the vertex changing up in the yellow box. And so I want 3, 8, click. So now I'm just moving my mouse and it's wanting to like do other things until it says in the yellow strip, click the graph to plot a point on your parabola. Well, I need something else. Well, it didn't guide me to find any other points. It guided me to find an axis of symmetry and its concavity in terms of up or down. So I'm gonna go back over here and we have to come up with another point. Well, a good thing to try is to take our function, I'm just rewriting it so that you can see, and find a y-intercept. That is when you let x equal 0. So g of 0 is negative of 0 minus 3 squared plus 8. So 0 minus 3 is negative 3. Square that, it's 9. So this is negative of 9 plus 8, which is negative 1. So I get the point 0, negative 1, which is another point. Specifically, it's the y-intercept, but it's another point I can plot. So that's what I'm going to plot, 0, negative 1. And I could have picked other points, but I just thought that would be an easy one. So 0, negative 1, click, and then I make sure that I have them where I want them. And then I can go ahead and save that. And then I can check this. And we did it. Okay. So that's how you can kind of use this tool. You do have to have another point. It didn't guide you to get another point until you opened up the little graphing tool with that. I see a question in the chat about, can you do a final exam through ProctorU as well? Yeah, all students in Math136 in the online course should be able to use either testing services through Ivy Tech or ProctorU. There is a small fee with ProctorU, and that should be stated in your syllabus. But yes, that is an option for that. All right, the next question is number 21 from that same 5A. And I'll pull up my list. Okay, so on this one, we're going to walk through this. It wants to know, does the graph open up or down? And so I don't really have to write anything for that. I'm just looking at that front value for A. This one is in the form ax squared plus bx plus c. I know that because it doesn't have parentheses with a square on it. So that's how I can tell what format it's in. Although in case we do need to write some stuff, I'm going to take a quick screenshot so I can put it over on my screen where I'm writing. So again, this is ax squared plus bx plus c for the format here. So I can see that A is 1, which is positive. So therefore, this should open up. So I can put that back in my answer and check that, and we're good. So now it wants to know the coordinates of the vertex. So this is now where I need to use the little formula because I don't have it in vertex form. So the B and the C from ax squared plus bx plus c does not mean the same thing as h and k that's in the vertex form. So it does say type an ordered pair and use integers and fractions. So I'm going to go back to where I can write. And so our formula is that to find h, let me write that more clearly. Find h, that's opposite of b over 2a, and to find k, you're going to take that and substitute it into your function to evaluate that. So in our equation, a, I already said, is 1. Looks like b is negative 8, and I don't need a c. But in this case, c is actually 0, but we don't actually need it for this formula. So that means to find h, opposite of b. Now this is where you have to be careful. B itself is negative. So I'm taking an opposite or negative of a negative because the formula comes with a negative sign in front of it. Okay. So negative of negative 8, which is going to be positive 8. Then k will be f of positive 8. Let me erase that. Okay. And so that means I'm taking my equation, x squared minus 8x, and in place of the x, I'm putting 8. Okay. And so that tells me, I'm going to grab my calculator, 8 squared, 64, minus 8 times 8. Oh, that's also 64. So this whole thing is 0. So that tells me, therefore, that hk is 8, 0. That's what I should enter. I'm going to pop back over and use my ordered pair notation, or I could have started typing parentheses. And I'm going to put in 8, use my arrow to bump over into the next blue spot and 0 and check my answer. And I obviously made a mistake. Let's double check that. Teachers make mistakes just like students. So let me, oh, yep, I did not divide by 2a. Thank you, Steph. Yes, I see that here. 2a, so that's 2 times 1. And so that is 4. Let's try that again. All right, so we plug in 4 squared, 4. Okay, so 16 minus 32. Yeah, totally different point. We get negative 16. So this is 4, negative 16. I'm going to do a quick check to make sure. Yeah, 4, negative 16. Okay, so now let's try that again. 4. Let's start the whole thing. There we go, 4, and then negative 16, and I'm going to get rid of the blue box. Okay, try that. There we go. We're all good now, thank you. Okay, then it wants to know what is the axis of symmetry. So we can get that directly from the x coordinate. So again, it says type an equation. So it's always a vertical line. So it always starts out x and then equals. And then it's always the x coordinate of the vertex, which is the h value. And so that's the 4. Check that. We're good. Right, then it wants to know about x-intercepts. And there could either be none, which is option B, or there could be one or more, because notice it says is/are. Use commas to separate as needed. So there could be more than one. So your x-intercepts then come from setting the equation equal to 0. So we had x squared minus 8x equal to 0. So I look at that and say, okay, how do I solve that? Well, I think I can try and factor. There's a common factor of an x. And now I use the zero product property where I split each of those factors and set each one equal to 0. The first one is already solved for me. It's x equals 0. The second one is linear. I add 8 to the other side. I get x equals 8. So I do have 2 x-intercepts that I'm going to enter with a comma. They can be in any order, but I need to make sure I have them in a comma. So I'm going to go back over. And I'm going to select A. And then it says just type an integer or a decimal. Notice it doesn't say type x equals. It's just type the number. So 0, I have more than 1, so I'm going to use a comma, and then 8. This is not an ordered pair. I'm not putting in parentheses. So again, math is a kind of language all of itself. So you want to make sure that you're putting things in the correct notation. So we're going to check that, and we're good. Then it says, what is the y-intercept? Okay, so the y-intercept is, instead of setting the function equal to 0, you're putting 0 into the function. So for the y-intercept, you're going to replace x equals 0 and find f of 0. So our function was f of x equals x squared minus 8x. So f of 0 will be blank squared minus 8 times blank. In place of the blank, I'm putting 0. And so that's all going to multiply to 0 in each product and then subtract and still have 0. So my y-intercept would be just the number 0 for that. So I go back to enter that. And we're going to say there is one. So I'm going to select A, and it just says type the integer or the decimal. So just literally the number. Okay. Now we're finally to the graphing part. Okay. So I'm going to click to enlarge this. And we're back to those tools again. So I pick what looks like a parabola. I want to plot the vertex. And we said the vertex was, what did we say it was? 4, -16. So I need 4, -16. Again, watch the coordinates in the yellow strip to know where you're plotting for sure. I know it's a little hard sometimes with the trackpad or a mouse. And then we need another point. Well, we just said the y-intercept was 0. That was when the x value was also 0. So that's 0, 0. So let me plot that. You have points to choose from, because obviously I could plot one of the x-intercepts as well, but I think I just got that on 0, 0. So pick whatever other points you need, and I'm going to click to save that and check it, and we're good. Okay, so again, the graphing tool, just follow that yellow bar and hover your mouse over things, and it'll kind of guide you as to what to do with that. Okay. Now this one, again, many of these problems have multiple parts. It talks about domain and range. So again, this says to put it in interval notation underneath this. And so if I do domain, that's everything from left to right on my graph. Well, the nice thing about parabolas is the domain is always everything. So because I want to do interval notation though, I've got to get my infinity and negative infinity symbols, which is down in the math palette, and then move my cursor over and then hit infinity. And then now it's going to ask me about the range. So the range is going vertically, bottom to top. So going from the bottom of your graph up, where's the lowest value? Well, remember the vertex was at 4, -16. That's at the bottom of my parabola. So the first y value that we can be equal to is -16, and then anything higher than that. And because there's an actual point plotted at -16, it includes -16. Therefore, as an interval, I need to use a bracket because I need to include the -16. I see a lot of mistakes where students put a parenthesis, but remember, parenthesis for an interval excludes the value. So I have bracket -16, comma, and I'm just using my keyboard. I'm not using the little palette for what looks like an ordered pair because I don't want the parenthesis. And then I'm going to go to infinity, and then I'm going to close with a parenthesis that, again, I just did from my keyboard. And there we go. Then it's asking for increasing and decreasing. So with a parabola, one side's going to increase, one side's going to decrease, depending on if it opened up or down. You go from left to right across the x-axis, though, to determine that. So where it's increasing is after the vertex. So remember, the vertex was at 4, -16. So once I get past 4 horizontally, the graph is going up. And then before that, I'm decreasing. So I need an interval. And we're going to do, I believe, if I remember correctly, it varies per textbook and material, but I believe your textbook includes with a bracket the intervals of increasing and decreasing. If I'm wrong, it'll just tell me I'm wrong and then I'll just re-enter it. But I've taught out of different material, different publishers, different textbooks, and different ones do it differently. But if I'm remembering correctly, yours does brackets. So I'm going to do bracket and then 4, infinity. So everything from 4 and to the right is where my graph is increasing because that's where you see it going up. Okay, I was right. So you include with a bracket your increasing and decreasing interval values, except for when you have infinity. So now where it's decreasing is the other side, which is starting from negative infinity going up to where the vertex was. So that's up into the 4. And so that's going to be parenthesis, negative infinity, comma, 4, again, bracket, because you're going to include that. And we're good. So that's that whole question. Okay. All right. So those are some things from 4.3. I'm not going to talk a whole lot about section 4.5. It's kind of similar to 5.5, but I am going to comment that when you are solving these, you're basically looking to see if you have something that is a greater than or possibly greater than or equal to. You're looking for where your function is above the x-axis. And if it was with equal to, that's above or on the x-axis, because the equality part allows you to be on the x-axis. But then if you are with less than or equal to, it's where your function is below the x-axis. And so again, if you had less than or equal to, that means below or on the x-axis. And because it says where, when you answer these, where are intervals, write that more clearly, intervals on the x-axis. So you're always looking from left to right, kind of splitting it up that way. It's going to be very similar to what we have in 5.5. And oh, I had already written on this. It's very similar to what I had in 5.5. And so I'm going to do a problem from 5.5, and it'll work very similarly as what you have in 4.5. Okay, because again, we're kind of short on time in terms of like what stuff can we talk about. So I'm going to jump to the 5B homework, number 2 in my lab. So I'm going to quit this one. And doesn't want to select this. There we go. And we're going to go to 5B. Number 2. Okay. So in this example, I'm going to get that where I can write here. The concept is the same as what you would be doing for a parabola. And so make this a little bit bigger. There we go. You have a graph, and part of it could be above the x-axis, and part of it could be below the x-axis, and part of it could be on the x-axis. Regardless of whether it's a parabola, like it would be in section 4.5 for quadratics, or if it's a polynomial, which could be like this section 5.5, or if it's a rational function that's an inequality, which is what I actually have on the screen. So this is a rational inequality. I know it's rational inequality because I see asymptotes. I know it's not quadratic because it doesn't look like a parabola. And I know it's not a polynomial because it's not smooth and continuous with increasing and decreasing and no asymptotes. But the concept is the same. So if we want to solve where is the graph, whoops, sorry, my pen and technology stuff tonight is just not working great. It's stuck on this green pen instead of a highlighter. Try this again. There we go. So where this is greater than 0, what that means is above the x-axis. So I'm looking at my graph and I'm saying, okay, where's my x-axis? My x-axis is right here that I traced over in orange, okay? That's my x-axis. So I want everything where my graph is above that. Well, I'm just going to trace over the parts of my graph that I see that are above. So I traced over in yellow there, the parts that are above. Now what I need is the where part. Where does that happen? So from left to right, I want to look along the x-axis and say, where does that happen? Well, if I start at the far left of my graph and I keep going, I get stopped by that asymptote that's at x equals -2. So I can only go up to that, but not include it. Well, that's an interval. That's from -infinity to -2 with an open parenthesis because I'm only going above the axis and not like including and being on it. And I have an asymptote, which isn't included anyway. So that part gives me that first yellow highlighted part. Then I say, okay, well, now I skip over to where it looks like this is starting at 0 and going up until, oops, I hit that next asymptote, which is x equals 2. So I can go up to that. So that's from 0 to 2, not including those. So I have two intervals, -infinity to -2 and 0 to 2. So that's what I should be able to enter for part A. It says use interval notation. So we had parenthesis, -infinity, comma, up to -2, parenthesis. Now I'm going to use the union symbol down here because that brings the two intervals together. So if you have more than one interval, union them together. And that's the one that looks like a regular U. And then we went from not including with a parenthesis 0, comma, 2, parenthesis, and then I check that. Okay. Now, if that had said instead greater than or equal to 0, then at 0, 0, at the origin, I could have included the point right there. And so I would have changed my second interval that has a parenthesis around 0 to have a bracket around 0, because then I can include it. That's the only difference I would make. So there's subtle differences. If I'm doing less than or equal to, which is the second part of the question, now if I do less than or equal to, I'm looking at below or on the x-axis, okay? So in my picture, I see this far right part, and I see this middle part up until the origin. And so again, I want to look at, well, what intervals are those? So it's to the right of my first asymptote. So it's basically in here. But because I can be on it, I'm actually going to change this to a bracket. So if you're a visual person, like draw these things on your paper from what you see on the screen and like start tracing things, and that might like help you. So that's from -2, not including it, up until 0 with a bracket. Then the next one starts to the right of the second asymptote, not including it and going off to infinity. So that means it's starting just after 2. So I don't include it with a parenthesis, and then I go to infinity. So that's what I should be typing in for that second answer. And so we've got parenthesis, -2, comma, 0 with a bracket because I want to include that. And then I use my union symbol again to bring these together. And then I go to the other side of the second asymptote with a parenthesis 2, comma, infinity. Close that with a parenthesis. Always use a parenthesis with infinity or -infinity. And there we go. So if this was a parabola, if this was a polynomial, you're still looking for the same things conceptually, okay? Look for what's above, what's below, or on. Include with brackets, exclude with parentheses. The next problem, number 19. On this one, this is going to break it down for you. So this type of problem, you're going to see, it wants you to kind of break it down and enter intermediate values. So let's go to 19. So again, I'm trying to pick a variety of different things. Okay, so this is where it's going to want you to put in everything into these boxes. It's going to ask for these intervals to kind of test this. And then you're going to be choosing whether something is positive or negative in these intervals. And you're going to complete this table. Okay, so let me grab this problem. And insert it over here. Okay. So this one, they did not provide a graph to us. So we want to kind of talk about the same things, but algebraically without having to graph the whole thing. So this is a rational inequality. This would be quite extensive to actually graph it, as you may recall from the material before your midterm, you graphed rational functions. But we don't need to graph it. We just still want that concept of, let's find what part of my graph is above the x-axis. Those would be positive values for y. And what part of my graph is below the x-axis? Well, those would be negative values for my function or y. And then what part might be equal to and on the x-axis? Well, that's where they're exactly equal to 0. So we're going to break this down. So it says list the intervals and the sign in each interval. So I got to get the intervals first. So notice there should be, because it's kind of prompting us, 1, 2, 3, 4, 5, 6 different intervals for this particular problem. Well, where do you figure out what those are? You do two things. And I think I have it over here. Man, my whole computer is just buggy. I apologize. I promise it was working just fine. I'm going to turn my camera off to see if maybe that helps, because maybe it's just like sucking too much power for this. Okay, well, that seemed to work a little bit. Okay, so you create intervals in two ways. You either find where the function is equal to 0, and that's listed here in number 2. So where is the function equal to 0? Or you see where is it undefined. And so that involves two things. It involves setting your denominator equal to 0, or it involves setting your numerator equal to 0. Okay. So you may have recognized that we had some factors already here. So this was already in factored form for us. And so if I want to look at this in two ways, I can find the zeros by setting x squared equal to 0, 4 plus x equal to 0, and x plus 5 equal to 0. So if I solve each of those, the first one, I get x equals 0, taking the square root of each side. The second one, I get x equals -4 by subtracting 4. And the next one, I get -5. So those gives me 3x values, okay? The other thing I can do is see where is this going to be undefined. That's going to be looking at the denominator equal to 0. So this will be undefined when the denominator equals 0. So that's x plus 6 equal to 0, or x minus 1 equal to 0. So that means this is x equals -6 or x equals 1. So now, where do I still get intervals? Well, I take, for those of you who are more visual, what would be an x-axis, and I say, okay, if I line up all those x values on the x-axis and mark them off from left to right, what am I left with? So I'm going to start with the most negative one. So it looks like -6, and this is not to scale. -6 is the first one, then it would be -5, then it would be -4, then it looks like I have 0, again, not to scale, and then I have 1, okay? So what does that do? That creates 1, 2, 3, 4, 5, 6 intervals from left to right. So that's what I'm writing to list the intervals in these 6 spots. okay? And I'm going to do that in interval notation. And so I'm going to do that by using all parentheses, no brackets. So this is going to be negative infinity to -6, close with a parenthesis. The next one, and stop me if I make a mistake. I'm going from memory what I had on the other screen, -6, comma, -5. The next one was parenthesis, -5, comma, did we have a -4? Yeah, we had -4. Then we jump from -4 to 0. And then we go from 0 to 1. And then we go from 1 to infinity. Okay. So again, I put them in as open intervals. They should always be open. When they're asking you to test these intervals and list out the intervals, you're not doing the same thing as like what you would do if you were looking to see where is it greater than or equal to or less than or equal to. We're not to that part yet. So we're not going to decide whether we should have a closed bracket or an open parenthesis. The intervals themselves are open. Your final answer that we're going to end up giving after this table is done is going to be where you decide if you have a closed bracket to include or exclude something. So now I've got them all in there. I'm not ready to check my answer yet because I have to decide, well, in each interval, do I have a positive or negative value? So what I do is I now take my function, right? This is my function, f of x, and I want the sign of f of x in each of these intervals. So I pick a test value, okay? So let's say I pick -7. Then let's say I pick -5.5, -4.5. Let's say I pick -1. Let's say I pick 0.5, and let's say I pick 2. All I did was pick a value along the x-axis that's in there, okay, in that interval. And we're going to evaluate f of x. So if I had -7 and I were to plug that everywhere I have an x, I need to know if I'm going to get an output that's positive or negative. That's all I need to know. I don't need to know the actual value. I just need to know if it's positive or negative. You can do this in your calculator if you want. Sometimes it's a little clunky typing it all in and you make mistakes. So the other thing you can do is just kind of use your head to look and say, okay, I don't need to know the actual number. I just need to know, like, size-wise, is it positive or negative? So no matter if these are positive or negative, when I do x squared, that's always going to be positive for all of those. So let's look at the other factors. If I had -7 to test this first one, and I had 4 plus -7, then this whole term is negative, or this whole factor. -7 plus 5, this one is negative. Well, if I multiply those together, that's positive. The bottom, if I had -7 plus 6, that's negative. And if I had -7 minus 1, that's negative. Well, now I have 4 negatives, 2 on top, 2 on bottom. With multiplication, even quantities of negatives are positive. With multiplication and division, and if I have an odd quantity, they're negative. So this whole thing should be positive, okay? Then I do the next number, -5.5 in the next interval, and I do the same thing. So if I had -5.5, I can ignore the x squared. This one will be negative. This will be negative on top. On the bottom, positive and negative. So now I'm going to have positive up top, negative on bottom. I'm going to divide, and the whole thing's going to be negative. I go to the next interval. I had -4.5. So -4.5, do the same thing. 4 plus -4.5, that'll be negative. The next one will be positive. On the bottom, positive, and then negative. So I'm going to have a negative divided by a negative, which is positive. The next one, I'm picking -1. So I put that in. Oops. Ignore the x squared. So -1, this will be positive, positive up top, positive on bottom, and -1 minus 1 is negative. So only one negative sign. This is negative. Then I picked 0.5, so a half. The top will stay positive, then positive, and then a half minus 1 is negative. Actually, that's going to be exactly the same. So this is going to be negative. And then the last one I picked a 2. So the top will be positive, positive, the bottom will be positive, and then I'm going to change this one to positive. So the whole thing is positive. So I should be able to go select positive, negative, then negative, positive. And hopefully I didn't make a mistake. I'm counting on you guys to tell me if I did. Positive, negative, positive, negative, and then this is where it switched. Negative, positive. Fantastic, okay? Now we need the actual solution. So the problem asked for greater than or equal to 0. So I'm gonna come back over here. Greater than or equal to 0. That means above or on the x-axis. So that's everywhere where you see a positive interval, okay, or equal to. So it's the first, the third, and the last. And then we just got to figure out, do we include or exclude? So here's the thing. When the function is undefined, you can never include. So that means I've got the first interval, the third interval, and the last interval. And this was undefined at -6 and 1. So I cannot include those. So I cannot include -6, it has to be a parenthesis. I cannot include 1, it has to be a parenthesis. And then the zeros, I can include those, -5 and -4. So I think that would be bracket, bracket, and everything in between, okay? So if I'm interpreting this correctly, I looked at all my information here, that's what I'm looking for. So if I go back, it gives me a multiple choice. So I kind of look to see, okay, do I have that answer here? It looks like D matches what I just wrote. And I encourage you guys to actually do that. Don't just eeny, meeny, miny, moe it or try and guess or go backwards. Like try and come up with it yourself and then look to see if your answer is in the multiple choice. And, oh, so apparently I did make a mistake somewhere. Where did I make a mistake? Let's see. Did I write something wrong here? I must have. So greater than or equal to 0, where we have positives, the -6 is undefined, the 1 is undefined, and the -5 and the -4, that was the 1, 2, that was the third. Okay. And then, wouldn't it be infinity? Yeah, let me go look and see. Oh, yes, it would be. Yes. So that is not D. Yeah, thank you. I was like, I knew I did. So I'm looking at the clock and I know we only have 2 minutes left. So I was like rushing and you're right. So it would be not answer B because that has a bracket around -6. So A, and it's not A because it has parentheses around the -5 and the -4. So I think we're down to C, but I'm just going to double check it all. So I've got the parentheses around the -6 that I wanted. I've got the -5 and the -4 with a bracket. But yes, I have to have from 1 to infinity, not 0 to 1. I misread that in part D. But here's what I have to also explain. In between the -5, -4, and the 1 to infinity, there's in braces just a 0. So remember, this included equality. And so this is where it is on the x-axis. So I need that single point. And so when we do that, we put it in braces with just that one single value. Excuse me. And so this was the 1 to infinity. This is the one single point. This is the inclusive interval that includes the -5 and -4. And this is the open interval up to -6. So that's union, that's union. And so again, this is a single point that we have to include, not a whole interval, because this includes equal to on the x-axis, okay? So we are out of time. I just want to end with a couple things. I didn't get a chance to do a problem from 5-6, but that's talking about real zeros of a polynomial. It takes a lot of things that you already know about, but I encourage you to read through your text. There's a lot of rules in this section, and I had already written on this, but I just pulled all these rules: the rational zeros theorem, Descartes' rule of signs, factor theorem. So study what these rules say and then apply them to your problems. And then don't forget things like, hey, you should know how to factor. So if you see something that can be factored as a polynomial, do that. If you see something that can be factored by grouping, do that. That's when you have 4 terms. So that works as well. So a recording of this will be back in the live lectures, probably updated tomorrow. The recordings get there the day after. And then if you wish to leave your feedback, we really appreciate it. You can click this link here. I will also copy it right now and put it in the Zoom chat. So if you can just do it right now to leave us feedback on these sessions, because we try as best we can to change things from week to week. I know a lot of students are asking for longer sessions. Unfortunately, that's one thing we can't change. We've got these kind of approved to do 1 hour. And it's only the midterm and the final exam week that we add some extra for review for the exams. But if you can give your feedback, that'd be great. And if you come back for week 6 and week 7, we'd love that. And then in week 8, we'll have multiple sessions for review in preparation for your final exam. So thank you for attending tonight, and I appreciate it. And good luck with your Module 5. You can reach out to your instructor if you need help at any time as well. Take care. Have a good evening.